Imagine this for a second. You're sitting at your desk, right? The ambient glow of your monitor is just reflecting off your glasses.
We have all been there.
Oh, totally. And you're staring down this massive, just sprawling problem. Maybe it's a deeply complex, I don't know, multi-layered Python architecture that just keeps throwing errors that you can't trace.
Or it's one of those soul-crushing administrative tasks.
Yes, exactly. Like a huge data extraction task at work. You've got a folder of like 50 different scan images, and you need to manually pull structured information from every single one of them.
Just brutal, low-value work.
Right. And you are staring at the screen, and you absolutely know, that artificial intelligence could solve this problem for you in like seconds.
But you hesitate.
Exactly. Your fingers are hovering right over the keyboard, but you aren't typing the prompt. You are just frozen.
It's a moment of paralysis that, honestly, almost every professional is experiencing right now. The tool is right there, but the friction to use it just feels way too high.
Yeah, and why are you hesitating? Well, maybe you're just exhausted from paying yet another $20 a month subscription fee for a premium AI tool.
Right. The subscription fatigue is so real.
It really is. You look at your bank statement and you just see all these microtransactions bleeding your monthly budget dry. Or maybe, and this is usually the biggest roadblock for most professionals, you are terrified of uploading your company's sensitive private data into a public cloud.
Or your own personal financial data, for that matter.
Exactly. You have absolutely no idea who is looking at it, where those servers are even located, or how your proprietary code is being used to train the next iteration of some mega corporation's model.
You're just handing it over.
Right. So you just sit there, you feel entirely stuck. You are caught right in the middle between, falling behind on the technological curve or compromising your budget and your absolute privacy.
Not a great feeling.
Yeah.
We want the computational power, but the hidden costs, both financial and in terms of data sovereignty, they just keep us locked out of the ecosystem. It creates this massive digital divide.
Yeah. But what if there was a completely different approach? What if I told you there was a highly secure, incredibly powerful alternative that flips this entire dynamic right on its head?
I'd say I'm listening.
Right. An alternative that was built like a Ferrari, but basically cost the price of a bicycle. Well, welcome to this special Cortex Lab deep dive.
It's a big one today.
It really is. We have synthesized a massive stack of the latest developer manuals, technical breakdowns, and architectural analyses to figure out how a relatively tiny startup is absolutely terrifying the Silicon Valley establishment.
It's quite the story.
So today's mission, we're going to guide you through the DeepSeek revolution, and we're going to extract exactly what you need to know by exploring 5 massive paradigm shifts or lessons you really need to understand to stay ahead of the curve.
What's fascinating here is how a completely unknown entity managed to disrupt a global tech monopoly almost overnight. I mean, we're not just talking about a cool new app here.
No, not at all.
We are talking about a structural earthquake in software engineering. It is forcing the biggest, most well-funded players in the entire industry to completely rethink their business models.
I am so ready for this. Okay, let's unpack this. We need to start with lesson 1, looking at what the industry is calling the efficiency paradigm. Because the origin story of this company, DeepSeek, is just wild.
It really rewrites the rules of how software is built.
Yeah, where did they even come from?
Well, to really grasp the magnitude of the technology, you have to understand the genesis of the company itself. DeepSeek wasn't born in a Silicon Valley garage,
Right.
and it wasn't spun out of a massive tech conglomerate like Google or Microsoft. It was actually founded quite recently, in May 2023, by a Chinese entrepreneur named Liang Wenfeng.
And from what I understand from the sources, his background is not what you would expect for an AI pioneer.
Not at all.
Like, he isn't a traditional tech bro who spent the last decade building social media apps, right?
No, exactly. Liang Wenfeng's background is deeply, deeply rooted in high finance and quantitative trading.
Oh, wow.
Yeah. Back in February 2016, he co-founded a hedge fund called Highflyer. Now, if you know anything about the quantitative trading world, you know it is a hyper-competitive environment.
Where milliseconds matter.
Precisely. Milliseconds can literally mean the difference between making millions of dollars or losing your shirt. So they spent years developing these bespoke artificial intelligence algorithms specifically for algorithmic trading.
Which I imagine requires a completely different mindset. I mean, if you are building consumer apps in Silicon Valley, the mantra has historically been move fast and break things,
Right?
right?
And if you run out of server space?
You just go raise another $100 million from a VC to buy more cloud compute.
Exactly. But in quant trading, it's entirely different.
Right.
When you are building algorithms for high-frequency trading, your entire ethos is built around optimization, speed, and extreme cost-effectiveness.
Because every ounce of latency is just lost money.
Yes. You are trying to find the absolute most mathematically efficient path to a result. You have to squeeze every single drop of performance out of your hardware.
Makes sense?
So eventually, Highflyer expanded their scope from purely financial algorithms into broader AI research. And that research division ultimately led to the creation of DeepSeek.
And wait, it was entirely funded by the hedge fund itself.
In fact, entirely internally funded.
So they were completely independent. They didn't have to go on some roadshow begging venture capitalists for funding, diluting their equity, making all these wild promises.
They had their own internal war chest.
That is huge. But okay, here is where the story gets really crazy. Let's look at the numbers behind their flagship model, DeepSeek R1.
The numbers are staggering.
Yeah. This is a model that objective benchmarks show matching, and in some cases even exceeding, the performance of giants like OpenAI's GPT-4. But let's look at the price tag for development.
Right. The training costs.
OpenAI reportedly spent over $100 million just on the compute to train GPT-4. $100 million. How much did DeepSeek spend to train R1?
So the estimates from the technical breakdowns are right around $6 million.
$6 million.
Yeah. And to be perfectly precise, one of the sources notes it might have even been as low as $5.5 million. But let's use $6 million as our working baseline.
6 million versus 100 million. I mean, that is literally a fraction of the cost. It's like building a Ferrari for the price of a bicycle.
It really is.
But I have to push back here because I've been around the tech industry long enough to know that you can't just magically bridge a $94 million gap just by having a good work ethic.
No, absolutely not.
Right. If they use cheaper parts or a fraction of the budget, doesn't the quality have to suffer somewhere? Is it hallucinating more? How exactly did they achieve this without building a fundamentally inferior product?
Well, that is the core of the efficiency revolution. And it's entirely rooted in that quantitative trading mindset we talked about. They didn't just buy cheaper parts and cross their fingers.
Okay, so what did they do?
They fundamentally changed the architecture of how the neural network actually operates. The primary method they deployed is a concept known as sparse modeling.
Sparse modeling. Okay, I know traditional large language models use what's called a dense architecture, where basically every single parameter fires at once when you ask it a question.
Exactly.
So how exactly is DeepSeek routing the queries to avoid that massive compute cost?
So to understand sparse modeling, we have to contrast it with those dense models. Think of a traditional, dense, large language model like a massive sprawling corporation.
Okay, I'm picturing it.
In a dense model, every single employee works on every single project, no matter what it is.
Wait, really?
Yeah. If you need a new logo designed for the company, the accountants, the janitors, the HR representatives, and the graphic designers all get called into a massive stadium to work on the logo together.
That sounds horribly inefficient.
It is. Every single time you prompt a dense model, the entire network activates.
So you are powering up billions of parameters just to answer a simple question like, what is the capital of France?
Exactly. It uses a staggering amount of electricity, memory bandwidth, and computing power. Sparse modeling, on the other hand, utilizes an architecture called Mixture of Experts, or MOE.
Mixture of experts, okay.
In this system, the AI is divided into highly specialized neural subnetworks, which we call experts. When you give DeepSeek a prompt, the model uses a sophisticated routing algorithm to analyze the request first.
Oh, so it acts like a triage nurse.
Exactly. It doesn't activate its entire massive network. It only wakes up the specific subset of parameters, the specific experts. They're strictly necessary to process that particular token.
So if you ask it a complex calculus question.
Only the math-focused experts wake up. The language translation experts, the creative writing experts, the coding experts, they all stay completely dormant.
But wait, if you have all these different experts just sitting there, how does the model know which one to wake up without wasting a ton of compute just figuring that out? Doesn't the routing itself take power?
It does. And that is where the engineering brilliance comes in. They developed incredibly lightweight router networks that make instantaneous, probabilistic decisions about where to send the data.
Wow.
Yeah, they managed to balance the load so efficiently that the computational overhead of the routing is just negligible, compared to the massive savings of leaving, like 90% of the network dormant.
Oh, wow. So they drastically reduced the computational weight of every single token generated?
Precisely. They massively reduced the total FLOP's floating point operations per second. DeepSeek consumes only a small fraction of the active computing power required for comparable dense models.
That is amazing.
But optimizing the architecture is only half of the equation. The other half of the $6 million miracle is their strategic hardware resourcefulness.
Right, we have to talk about the physical chips. Because, I mean, you cannot train a world-class AI without massive clusters of GPUs.
No, you can't.
And historically, that has meant buying tens of thousands of top-tier NVIDIA chips. But there are strict U.S. export sanctions that prevent the absolute most advanced NVIDIA hardware from crossing the border into China, right?
That's correct.
So how did a Chinese startup train a model that rivals GPT-4 without full, unfettered access to the absolute best silicon on the market?
Well, they had to use a highly complex hybrid approach.
Yeah.
Now, they did manage to secure a very large cluster of hardware before certain restrictions, tightened estimates suggest they utilized anywhere from 10,000 to 50,000 NVIDIA A100 GPUs.
Okay, so they had a good foundation.
They did. But to maximize efficiency and bypass the inevitable hardware bottlenecks, they couldn't just rely on perfectly uniform clusters of the newest chips. They mixed those high-end A100s with older, budget GPUs and even alternative chips from AMD.
But wait, anyone who has ever built a computer knows that mixing different types of processing units usually creates massive latency.
Oh, a nightmare of latency.
Right. If you have a really fast chip trying to talk to a really slow chip, the fast chip just ends up sitting there waiting, which wastes time and money.
That is exactly the problem with heterogeneous clusters, and it is notoriously difficult to solve. The networking interconnects, basically how the chips talk to each other across the servers, become a massive bottleneck.
So how did they fix it?
Liang Wenfeng's team engineered their way out of it. They wrote highly customized, low-level software to manage the communication between these disparate chips. Furthermore, they utilized a technique called FP8 precision.
Hold on, FP8 precision. What does that actually mean in practice? Are they just mathematically rounding numbers up and down to save time? Because that sounds like it would lead to a lot of errors.
It's a bit more nuanced than simply rounding up or down, but you are on the right track regarding saving memory space. In computing, precision refers to how much memory is used to store a single number.
Okay.
Traditionally, AI training uses 16-bit or even 32-bit floating point numbers. This provides incredible mathematical precision.
But moving those large numbers around takes a massive amount of memory bandwidth, right?
Exactly. FP8 stands for 8-bit floating point. By deliberately lowering the precision of certain calculations during the training process, you essentially cut the memory bandwidth requirements in half.
But if you lower the precision, doesn't the AI get dumber?
If done poorly, yes, absolutely. The AI can suffer from severe degradation in its logical reasoning.
So how did they avoid that?
The absolute genius of DeepSeek's engineering team was figuring out exactly which calculations could tolerate 8-bit precision without losing the overarching logical accuracy of the model, and which calculations required higher precision.
Oh, so they mixed the precision levels.
Exactly. They built custom pre-processing pipelines that constantly adjust this balance dynamically. They squeezed every single ounce of performance out of the disparate hardware cluster they had.
They didn't just throw an infinite pile of venture capital money at the problem like the Western tech giants. They actually engineered their way through the physical limitations. Okay, so they built this incredible architecture. They made it wildly cheap to train, and because of the mixture of experts, it's wildly cheap to run. But let's bring this back to the person listening right now.
Sure.
Why should you or I care about DeepSeek's internal server costs or their clever routing algorithms?
Because the economics of this breakthrough don't just stay inside the company, they cascade outward and fundamentally alter the market.
Explain that.
DeepSeek is passing those operational savings directly to the developer and the consumer. If you are an independent developer or a business owner trying to integrate advanced AI into your own proprietary application, the cost difference is night and day.
Okay, give me some numbers.
Consider the standard API pricing.
Yeah.
The API, the application programming interface, is basically the pipeline developers use to plug an AI model into their own software.
Right.
Currently, utilizing a top-tier model, like OpenAI's GPT-4, through their API, costs roughly $7.50 per $1 million input tokens.
Okay, $7.50. I mean, that doesn't sound like a lot in isolation.
No. But if you are running an app that processes thousands of user queries a minute or reading massive databases.
Oh, right. Those tokens add up incredibly fast. You can burn through tens of thousands of dollars a month easily.
Exactly. Now compare that to DeepSeek. DeepSeek's API provides comparable logical performance, but it costs zero point 0.1 cent per million tokens.
Wait, 14 cents?
14 cents.
You're kidding. That is roughly a 98% price drop. That is, what, 27 times cheaper for the exact same volume of processing?
It is an absolute collapse of the pricing floor.
That is just absurd. If I am running a tech startup and my primary overhead is my cloud AI compute bill, switching to this API drops my monthly expenses from, say, $5,000 down to the cost of a couple of lattes.
It extends a startup's runway by years.
Wow. And that is precisely why this is causing such a massive shockwave across the tech industry. It completely disrupts the underlying business models of companies that are relying on high monthly subscription fees and expensive premium API access.
Just to recoup their $100 million training costs. DeepSeek has essentially commoditized intelligence.
Which is a beautiful transition into lesson 2, the second major paradigm shift we need to discuss. Because making this technology cheap is one thing. That is a massive achievement in its own right.
Oh, absolutely.
But how they decided to distribute this technology to the world is even more disruptive. Let's talk about the open source rebellion and what it means for total data privacy.
This is where DeepSeek departs from the traditional Silicon Valley playbook entirely. For the last few years, companies like OpenAI, Google, Anthropic, they have kept their most advanced foundational models strictly locked away.
Right, proprietary models.
Exactly. They are closed source. You can interact with the AI through a clean user interface on a website, but you can never see how it is built. You cannot look under the hood.
It is a complete black box. You ask a question, the data goes into their servers, the magic happens in the dark, and you get an answer spit back out. The recipe itself is a closely guarded corporate secret.
DeepSeek went in the exact opposite direction.
Real.
Yeah. Because they built their models so efficiently, they didn't have a $100 million investment that they desperately needed to protect with walls and moats.
Right. They only spent $6 million.
Exactly. This financial freedom allowed them to do the unthinkable. They made the entire architecture open source. They published their underlying code, their weights, their routing mechanisms. They basically gave their secret sauce away to the global public.
But why? I mean, why would a company spend $6 million, which is still a massive amount of money, for a startup developing a world-class AI, and then just hand the blueprints over to their competitors for free? What is the business play there?
It is a profound philosophical and strategic shift. By releasing the model as open source, DeepSeek is actively trying to move artificial intelligence away from being a centralized monopoly controlled by 3 or 4 Western megacorporations.
Okay.
They are attempting to turn AI into a multipolar global public utility. By opening the code, they invite developers, academic researchers, and hobbyists from every country in the world to download it, audit it, modify it.
To tweak it for highly specific industries.
Exactly. And to improve upon it collectively. It massively accelerates global innovation because everyone can contribute to the foundation.
Okay, I conceptually love the democratization aspect of that. It feels very rooted in the original ethos of the early internet.
Sure.
But let's bring it back down to earth for the listener who isn't a Silicon Valley software engineer, you know?
Sure.
What does open source actually mean for them? I like to think of it this way. Using a proprietary closed source AI, like ChatGPT or Claude, is essentially like renting an apartment in a massive high-rise.
Yeah, I like this.
You can arrange your furniture however you want. You can live there comfortably, but the landlord ultimately owns the building.
Right.
The landlord holds the master key. They dictate the rules of the building. They can change your rent at any time. And realistically, they can see everything you bring inside.
And with the DeepSeek?
With DeepSeek's open source model, it's like they give you the raw bricks, the mortar, and the architectural blueprints so you can build your own house on your own private land.
That is a very apt analogy. And building the house on your own land brings us to, perhaps, the single most critical benefit of this entire open source movement, particularly for enterprise users, corporate IT departments, and privacy-conscious individuals.
Which is...
Local hosting.
Yes, the ultimate privacy play. We have to talk about how this actually works in practice, because this is where the hesitation we talked about at the very beginning of the deep dive completely vanishes. Let's talk about Ollama.
Right. This is where a fantastic open source tool called Ollama comes into play.
Okay.
Because DeepSeek's code is freely available, you are not forced to interact with it through a web browser where your data is transmitted across the internet to a centralized cloud server.
Okay.
Using a llama, which basically acts as a lightweight management client for large language models, you can literally download the DeepSeek R1 model directly onto your own local hardware.
So on my laptop.
Yes, you can put it on your company's internal server or even right onto your personal desktop or laptop.
Wait, let's be incredibly clear about this. You are saying I can download this world-class intelligence, pull the Ethernet cable entirely out of the wall, turn off my computer's Wi-Fi, and the AI will still function perfectly.
That is exactly what I'm saying.
Oh, wow.
Zero internet connection is required once the model weights are downloaded. All of the processing, all of the computational inference happens locally on the physical silicon inside your own machine.
That is absolutely massive. Think about the real-world implications of that for a minute.
They're huge.
If you work in the healthcare sector, right, and you are dealing with highly regulated patient records, or you work in a corporate law firm analyzing highly confidential M&A case files.
Or you're a lead developer working on an unreleased code base.
Exactly. You cannot legally, ethically, or logically paste that information into a public cloud AI interface. The risk of data leakage is simply too high. You don't know if that cloud provider is using your sensitive beta to train their next model.
Which might inadvertently spit your private code back out to a competitor 6 months from now.
Right.
Precisely. And this isn't just paranoia. It is a well-documented risk. Public cloud providers have massive terms of service agreements that often grant them broad rights to analyze user inputs.
But with local hosting.
By using a tool like a llama to run DeepSeek locally, you achieve absolute data sovereignty. Your prompts, your documents, and your data stay strictly within the physical confines of your own hard drive.
No third-party server ever processes it?
Never. It completely evaporates the privacy barrier that has prevented so many major corporations and strict regulatory environments from adopting AI tools.
So you own the house, you own the land, and the curtains are drawn tightly shut. Nobody is looking in, and nobody is listening. I love that.
It changes everything.
It does. But it
Yeah.
brings us to a really important practical question. Owning the house is great. Total privacy is fantastic. But what actually happens when you walk inside and start interacting with this thing?
There's the next big hurdle.
Right, because we are used to interacting with AI in a very specific conversational way. How does DeepSeek actually think compared to what we are used to? This takes us to lesson 3. Understanding the logic engine versus the storyteller. Because these tools are not interchangeable.
No, they are not. This is a crucial distinction for anyone looking to integrate this into their workflow. We need to be very clear that DeepSeek and standard models like ChatGPT are not identical twins.
Okay, how are they different?
They have wildly different specializations based on how they were trained. DeepSeek was specifically engineered and fine-tuned to be a coding and mathematical powerhouse.
Yeah.
It is a logic engine.
So it's not the tool you go to when you want to write a novel.
Exactly. If you need a highly nuanced, witty marketing campaign, a deeply emotional email, a funny poem for a friend's wedding, or creative storytelling models like ChatGPT or Claude remain the undisputed leaders.
They are the storytellers.
They excel at generating human-like, nuanced text. However, if you need to architect a complex database, write intricate scripts in Python, C++, or Java, or solve incredibly dense, multi-layered mathematical equations,
And then what?
DeepSeek is often the superior, far more rigorous tool.
So it's about picking the right tool for the exact job at hand. If I want to write an engaging blog post, I stay with the storyteller. But if my code refuses to compile after 3 hours of debugging, or I am staring at a massive broken spreadsheet, I need the logic engine.
Correct. And to fully unlock that deep technical power within DeepSeek, you have to understand how to utilize its most potent and unique feature,
Yeah.
the Deep Think mode, specifically the R1 reasoning toggle.
Here's where it gets really interesting. I like to conceptualize standard AI chat interfaces, like driving a modern car in automatic transmission.
Okay.
It's smooth, it's easy, it's fast. You just press the gas pedal and the car goes. It's fantastic for everyday, straightforward questions. But toggling that deep think button, which is located right on the main interface, is like manually dropping a massive truck into four-wheel drive low gear.
That's a great visual.
You don't use it to cruise down the highway. You use it when you are staring at a massive vertical technical boulder that you have to slowly and methodically crawl over.
That is a brilliant way to frame it. When you toggle Deep Think, You are manually shifting the AI out of standard rapid-fire response mode and forcing it into an advanced System 2 reasoning state.
System 2 reasoning, so it slows down.
Yes, it is specifically designed for multi-step logical problem solving. Instead of just probabilistically spitting out an immediate answer based on the first thing that comes to its computational mind, it actually takes time to process.
Whoa, wow.
It reasons through the logic sequentially, and it explicitly shows you its internal work before delivering the final output.
I saw a fascinating example of this in the architectural breakdowns we reviewed. A user uploaded an image of a deeply complex mathematical integral, like we are talking high-level college calculus here, and they turned the deep think mode on. The AI didn't just flash a final number on the screen, it actually output a block of text detailing its internal monologue.
It shows its work.
Yeah. It broke down the power rule, it explicitly stated why it was choosing a specific substitution method, it worked through the algebra step by step, and only then did it solve the equation perfectly. It was like watching a mathematician think out loud.
It is remarkable to observe. However, it is worth noting a small caveat regarding the user experience and the visual formatting.
What's the caveat?
Because DeepSeek is fundamentally prioritizing raw logical accuracy and mathematical rigor over aesthetic presentation, its visual output, how the mathematical formulas are actually rendered and formatted on your screen, might feel a bit clunky.
Ah, so it's not pretty.
Right. It might be unpolished compared to the beautiful typeset equations you might get from other commercial platforms.
Got it. So it might not look like a perfectly formatted PDF textbook, but the underlying math is absolutely bulletproof.
Exactly. The core advice for users is to focus entirely on the rigor and accuracy of the technical results rather than getting distracted by the visual layout. It is a utilitarian tool built for exactness.
Okay, so knowing what the AI is exceptionally good at is half the battle, but understanding the raw mechanics doesn't help much if you don't know how to actually apply it to your daily life.
Very true.
So let's transition into Lesson 4, Real-World Workflow Magic. We are going to extract some highly practical, actionable use cases from the manuals that you can deploy right now to immediately save yourself time.
The documentation provides some excellent, tangible examples of how to seamlessly integrate this logic engine into mundane daily tasks.
Let's start with visual extraction, or OCR, optical character recognition. This is an absolute game changer for anyone doing manual data entry.
It really is.
Imagine you have a physical piece of paper or a screenshot of a terrible presentation slide. The example used in one of the guides was an image of a simple, unformatted list detailing the pros and cons of eating bananas.
Right, a very basic visual asset.
Yeah.
It had bullet points like rich in nutrients like potassium, scrolled on the pro side, and high sugar content on the con side.
Normally, if you have an image of text, especially messy or unstructured text, you have to sit there, split your monitors, and manually retype everything line by line into a Word document or an Excel spreadsheet.
Tedious, low-value work.
Exactly. But with DeepSeek, the workflow is entirely frictionless. The user simply dragged the image file, dropped it directly into the chat box, and typed a one-sentence prompt, create a structured table from the text in this image.
And it did it.
Within seconds. The AI not only read the text, but comprehended the relationship between the items and generated a perfectly formatted, editable markdown table.
That's incredible.
Think about scaling that up. Think about doing that with a massive scanned financial invoice, a printed inventory manifest, or a complex employee roster. You can digitize and structure physical data almost instantly.
The efficiency gains for administrative tasks are enormous. However, we must ground this enthusiasm by reminding the listener of the operational constraints.
Oh, right, the limits.
You cannot simply dump an entire corporate hard drive or a 1,000-page PDF into the chat box and expect it to parse the whole thing instantly.
That would be nice, but no.
The system architecture enforces strict limits. It allows a maximum of 50 individual files per chat session, and each individual file cannot exceed 100 megabytes in size.
Okay, that is a very important technical boundary. Keep it under 50 files and 100 megs per chat, or you will hit an error wall.
Exactly.
Okay, let's look at another workflow hack, and this one genuinely blew my mind. It's what developers are calling native code execution. We established earlier that DeepSeek is a coding powerhouse.
It is.
But it goes beyond just writing the text of the code. A user challenged the AI to write a fully functional JavaScript snake game. You know, the classic retro arcade game where the little pixel snake eats the dot and grows longer.
Yes, a foundational, multi-layered coding exercise that requires HTML for structure, CSS for styling, and JavaScript for the interactive game loop.
Exactly. So the AI churns out the complete code base.
Mm.
But here is the absolute magic part. You do not have to copy that raw text. Open up a separate code editor like VS Code, paste it in, save the file, and spin up a local server just to see if the game actually works.
You don't?
No.
Mm.
Right there, directly inside the DeepSeek chat interface, it generates a button that simply says Run HTML.
Oh, wow.
The user clicked that button, a discrete window rendered right inside the chat timeline, and they were literally playing the fully functional Snake game right there in the browser.
And the workflow becomes incredibly iterative from that point. When the user was playing the game and felt the snake was moving far too quickly, they didn't have to manually hunt through the JavaScript to find the exact variable controlling the speed.
Right, they just talked to it.
They just typed a natural language follow-up prompt. Make the snake slower. The AI instantly comprehended the context, located the set timeout function within the game loop, updated the millisecond delay to reduce the frame rate, and instantly re-rendered the playable game.
That is just brilliant. It dramatically lowers the barrier to entry for software creation. You can just rapid prototype right there.
It really does.
Okay, here's one more workflow hack, and this might be my favorite because it applies to literally everyone, not just programmers. It's the explain to a kid prompting framework.
This is a remarkably powerful pedagogical technique for deconstructing and digesting immensely complex concepts.
Say you are trying to understand a wildly abstract topic like quantum entanglement. If you go to Wikipedia and search for quantum entanglement, you will be hit with a wall of dense physics jargon, wave functions, and superposition theory.
And your brain will probably melt out of your ears within 2 minutes.
Exactly. But if you take that topic to DeepSeek and explicitly frame the prompt by saying, explain quantum entanglement to a child, the logic engine is forced to abstract the complexity and find relatable anchors.
In the example we reviewed from the manuals, the AI responded with a brilliant, highly visual analogy about magic coins.
Oh, I loved this part.
It completely bypassed the advanced mathematics and said, imagine you have 2 deeply magical coins. If you flip one coin and it lands on heads, the other coin will instantly know and it will automatically land on tails no matter how far apart they are, even if one coin is sitting on Earth and the other coin is all the way on the moon.
I absolutely love that. And it followed up by saying, they are connected by an invisible string that we can't see, and scientists don't fully understand how the string works yet.
It's perfect.
That is such a vivid, perfectly accessible way to grasp the fundamental nature of a terrifyingly complex subject. It proves that you can use a high-level logic engine to simplify your learning process.
It perfectly highlights the model's ability to fluidly adjust its communication and pedagogical approach based entirely on the constraints you set in the prompt. But, as with any emerging technology, we have to acknowledge that it is not flawless.
Right, which leads me to a very practical troubleshooting question. What do you do when the AI just hangs? Because there is nothing more frustrating than an AI stopping dead in the middle of a brilliant sentence or freezing while trying to execute a web search.
This happens frequently, especially when the model is utilizing its live web search function to pull in real-time data about recent events.
Yeah, I've seen it just spin and spin.
The routing can encounter latency or hit a firewall, causing the output generation to pause indefinitely. The solution is almost laughably simple, yet incredibly effective. You just locate and click the Continue button on the interface.
Wait, you literally just click Continue, it doesn't break the context or start over.
You just click Continue. It acts as a manual override that prompts the model to push through the temporary bottleneck, reinitiate the query, and resume generating exactly where it left off.
That is so simple.
And speaking of time-saving interface quirks, the manuals are very explicit about another user habit. You need to stop wasting your time meticulously fixing your typos.
Oh, thank goodness. I spend half my time backspacing because my thumbs are just too big for my keyboard on my phone.
The natural language processing layers, the parts of the model that interpret what you are asking before it generates a response, are robust enough to parse your actual intent, even if your spelling or grammar is completely atrocious.
So it knows what I mean even if I misspell every third word.
Exactly. Meticulously correcting minor typos before hitting send is, as the documentation bluntly states, just a waste of time.
I feel incredibly validated. Just type terribly, hit enter, and let the billion-parameter brain figure out what you meant. I have to admit, I am highly enthusiastic about all these features. It feels like we're being handed a superpower for free.
This raises an important question, though. With any powerful tool, there are inherent risks and strict limitations. We cannot look at this through a purely utopian lens.
Fair enough.
To use this technology responsibly, we must critically examine its boundaries, its flaws, and the broader context in which it operates.
And that grounds us in Lesson 5, the final major area we need to unpack today, navigating the pitfalls in the geopolitics. Because if you read through the technical literature, there are very explicit warnings about security vulnerabilities, mathematical edge cases, and the unavoidable political realities of using a tool built in the specific regulatory environment.
Let's start with the most immediate threat, security.
Okay, what are we looking out for?
Because DeepSeek has experienced such an explosive, unprecedented surge in global popularity over a matter of weeks, malicious actors are moving incredibly fast to capitalize on the hype.
Of course they are.
The primary vector for this is the mobile application ecosystem. The security briefings explicitly warn users about the proliferation of sophisticated scam apps.
You mean fake apps masquerading as the real thing in the official stores?
Exactly. If you simply type DeepSeek into the search bar of a mobile app store, you will likely encounter dozens of third-party applications designed to perfectly mimic the official logo and interface.
That is dangerous.
Extremely. Downloading and granting permissions to these counterfeit apps can severely compromise your device's security, potentially exposing your personal data or locking you into predatory subscription models for a service that is supposed to be free.
So how do we stay safe?
You must be hyper-vigilant. Ensure you are exclusively downloading the official DeepSeek R1 application directly from the verified Apple App Store or Google Play Store, or ideally by following the direct download links hosted on their official website, chat.deepseek.com.
Okay, verify the source. It is basic internet hygiene, but when the hype cycle is this intense, people definitely get sloppy.
They do.
Now, what about the actual limitations of the logic engine itself? You called it a mathematical powerhouse earlier, but the literature contains a very specific warning about where the math breaks down.
Yes, and this is where blind trust becomes dangerous. While it is exceptional at standard calculus and algorithmic logic, it is not an infallible oracle.
Okay.
The architectural analysis specifically highlights a vulnerability regarding improper integrals with discontinuities.
Oh, okay. You are going to have to translate that for those of us who haven't taken calculus in like 15 years. How does an AI fail at math?
Let me simplify the concept.
Yeah.
In calculus, you often calculate the area under a curve on a graph. But sometimes you encounter a curve that doesn't just smoothly connect point A to point B.
Right.
Instead, at a specific point, say right at the 0 mark on the x-axis, the curve suddenly shoots straight up into infinity. That is a discontinuity. The math inherently breaks down.
Okay, I follow.
The AI, because it is fundamentally built on statistical probability and pattern matching, rather than pure symbolic logic, can sometimes stumble profoundly on these infinite edge cases.
So what does it do? Does it just error out?
No, that's the danger. It might hallucinate a neat finite number for an equation that actually diverges into infinity.
Ah, so it tries to force a logical answer where a logical answer doesn't actually exist because its entire job is to predict the next logical token.
Exactly.
So you absolutely cannot just blindly trust the output when you are dealing with high-level engineering or physics math.
Never. The documentation strongly encourages strict critical thinking and manual verification. While testing shows DeepSeek correctly identifying divergent integrals in many scenarios, the vulnerability remains.
Good to know.
You must remain acutely aware of these technical pitfalls. Always verify complex mathematical outputs through secondary solvers.
Trust, but meticulously verify. And speaking of things we need to view critically, we have to tackle the geopolitical realities of DeepSeek. We mentioned at the very beginning that Liang Wenfeng founded this in China.
Yes, we did.
And building a foundational AI model within that specific national jurisdiction comes with highly specific, non-negotiable constraints.
Yes, and it is vital to understand this context. DeepSeek, like any corporate entity, operates entirely under the regulatory and geopolitical framework of its home country. The data and the documentation we reviewed explicitly note that the AI is hard-coded with specific censorship protocols regarding sensitive political figures and events.
Can you give me an example of how that actually manifests if I am using the tool?
Certainly. If a user inputs a politically sensitive query or attempts to initiate a debate regarding prominent figures like Chinese President Xi Jinping or Russian President Vladimir Putin, the AI does not engage in a nuanced discussion.
What does it do instead?
It is programmed to abruptly and firmly redirect the conversation away from the topic altogether. It will often output a canned response stating it cannot assist with that request, and then immediately pivot to offering help with completely neutral technical subjects.
Like writing code or solving a math problem.
Essentially, yes.
So it literally just changes the subject.
But
I can't talk about geopolitics, but hey, do you want to write a Python script?
that's right. It
Yeah.
is a rigid, programmed boundary that reflects the legal compliance required for the company to operate.
So what does this all mean for us? Why is this important to acknowledge?
It's about setting the right expectations.
Exactly. It means we need to clearly understand the nature of the tool we are holding in our hands. I like to use this analogy. You wouldn't take a highly calibrated, state-of-the-art digital thermometer outside and try to use it to measure the speed of the wind.
No, you wouldn't.
It is a brilliant tool, but it is the wrong tool for that specific job. DeepSeek is a specialized, incredibly powerful instrument designed for logic, mathematics, coding, and hyper-efficiency.
Right.
You use it for its staggering technical strengths, and you respect its geopolitical and technical boundaries. You don't go to this specific model expecting an uncensored philosophical debate on global political science because it was fundamentally not built nor legally permitted to give you that.
That is the most responsible, mature way to integrate any new disruptive technology.
Mhm.
You have to understand its strengths, you have to acknowledge its weaknesses, and you have to be fully aware of the broader context that shaped its creation. It is a tool, not a perfect, omniscient intelligence.
Wow. We have covered an immense amount of ground today. Let's pull all 5 of these massive paradigm shifts together so we can see the full picture.
Good idea.
We started out by exploring the $6 million efficiency miracle. We learned how a hedge fund's obsession with optimization led to sparse modeling, mixture of experts, and the brilliant hybrid hardware engineering that bypassed traditional financial bottlenecks.
From there, we examined the open source rebellion. We saw how relinquishing control of the code empowers users globally, allowing them to host the AI locally via Olama, ensuring total data privacy and sovereignty for sensitive enterprise information.
We looked deeply at the logic engine versus the storyteller, learning that toggling the DeepThink R1 mode is like dropping into a heavy-duty gear to methodically crawl over complex, multi-step coding and mathematical problems.
We reviewed highly practical workflow magic, moving from dragging and dropping images for instant data extraction to running native HTML games directly within the browser and utilizing the Explain to a Child prompting framework to digest complex topics.
And finally, we navigated the serious limitations. The necessity of avoiding counterfeit applications, the importance of double-checking edge case mathematics, and the reality of navigating the political censorship constraints inherent in a globally distributed, multipolar AI ecosystem.
That's a lot to take in.
It is. But why does this all matter to you sitting at your desk right now? It matters because this technology fundamentally democratizes high-level computational power. It means you, as an individual or a small business owner, no longer need a massive corporate budget to access world-class artificial intelligence.
It saves you an incredible amount of money, it protects your proprietary data, and it dramatically increases your daily efficiency if you know how to wield it correctly.
It represents a structural leveling of the playing field across the entire digital economy.
Exactly.
So, here is my direct challenge to you, the listener. I want you to take one specific, actionable step today based on what we've unpacked in this episode. I want you to open a new tab and go to chat.deepseek.com or download the official verified app on your phone. Create a free account. Then, I want you to locate that DeepThink R1 reasoning toggle and turn it on. Think of a dense, complex topic that you are currently struggling to understand. Maybe it's a difficult concept for a university class, or a highly technical manual you are trying to parse at work.
Oh, this is a great exercise.
Ask the AI to explain that exact topic to you, but make sure you end your prompt with a specific phrase, explain it to a child. Watch how it breaks the complexity down. Experience that aha moment of clarity for yourself.
I highly recommend that exact exercise. It is by far the most effective way to internalize the pedagogical power and the reasoning capabilities of this specific tool.
Well, thank you so much for joining us on this Cortex Lab deep dive. We absolutely love breaking these massive, intimidating technological shifts down for you, making them accessible, practical, and hopefully a little fun along the way.
If we connect everything we've discussed today to the much bigger picture, I want to leave you with one final lingering thought to mull over as you go about your week.
Lay it on us.
We have just witnessed a relatively unknown startup utilizing a completely different engineering philosophy, match the absolute pinnacle of AI development for a mere fraction of the expected cost in a matter of months. If that level of disruption is possible today, what does this actually mean for the future of technology monopolies?
That's a huge question.
Are we standing right at the threshold of a new era where world-class artificial intelligence is no longer an expensive, premium luxury product locked behind a corporate paywall, but instead becomes as free, as customizable, and as universally ubiquitous as the air we breathe?
And if that is true, wait, I mean, if that is true, what will you build with it?